Today's experiment is characteristics of Zener diode. In this experiment, we have to do the analysis of VA characteristics experimentally, as well as we have to verify the results with the simulation results. Right? So the components required are Zener diode, resistors, and then breadboard. To measure the voltage and current, we require voltmeter and ammeter. And here you can see the connection diagram of Zener diode, that is a forward bias connection diagram of Zener diode. We are using a C5V1 as a Zener diode. So it means that the 5V1 indicates 5.1 voltage is the rating of this Zener diode. So forward characteristics means the positive supply is connected to the anode and the cathode is connected to the negative of the RPS, that is regulated power supply, and the resistor we are using it as 2.2 kilo ohm, and this arrow indicates the diode will conduct current only in the forward direction, right? So during forward bias case the current will be more, so I have taken the ammeter range as 0 to 30 milliamps, and during that time the voltage will be low, so the voltmeter range is 0 to 1 volt, and we are doing a DC analysis, so we are taking MC, that is moving coil type meter. So that means MC means moving coil type meter, and this is the circuit diagram connection, and you can see the tabulation over here. Here we are verifying the practical value with the simulated value, and we are analyzing the forward characteristics. So for the applied voltage, what will be the forward voltage and what will be the forward current we have to measure. So the forward voltage means the voltage drop across the Zener diode, and forward current means current flowing through the Zener diode. Right? So for a particular that is for the applied set voltage, what is the forward voltage and forward current we have to measure, and for those value can be verified with the help of multi-sim simulation tool. And here you can see the practical setup of the experimental setup of Zener diode, and before turning on the circuit you just know the terminal of Zener diode. So here I am having C5V1 Zener diode, and in this you can see the black coating over this diode. So this terminal indicate the cathode of the diode, and opposite terminal is called as anode of the diode. So as already I said, the anode is connected to the positive supply positive, and cathode is connected to the RPS negative, means that is called as forward characteristics. So before turning on the circuit, you must ensure the RPS is in 0 volt, and switch on the supply, and you can see there is no variation in voltage and current. Gradually I am going to increase the supply. So for the 0 applied voltage, the forward voltage is 0, and due to that the current also is 0. Now I am increasing the forward voltage. You can see the variation in the meter. So this voltmeter is used to measure the forward voltage, and this ammeter is used to measure the forward current. Now I am increasing the applied voltage. So due to that I can able to see the variation in the, that is drop across the forward Zener diode. So that is for 0.5 volt drop. If I am increasing the applied voltage, I can see the drop across the device. So the variation is only within the range of 1 volt, and you can see the variation. The forward current is getting increased. You can see the variation. So this is forward characteristics. So to measure, that is to draw a graph, we have to note down the reading. So initially the applied voltage is 0, forward voltage is also 0, and forward current is 0. Now I am increasing the forward voltage. So now you can see the forward voltage is 0.4 volt, and the current is very less. So if you increase the forward, that is applied voltage, the forward voltage is getting constant, nearly constant, and the current is getting increasing. And For all the values, there is 8 to 10 readings, we have to make a note, and corresponding waveform we have to draw. Here you can see the VA characteristics of Zener diode. So in the x-axis, so this is called forward characteristics of Zener diode. In x-axis I have taken the forward voltage, that is VF, and in y-axis I have taken forward current, right? So initially up to 0.6 voltage, that we can call it as cut-in voltage. So up to 0.6 voltage the current is 0. After the cut-in voltage, the diode, that is forward current, is getting increasing. So this characteristics is called the forward characteristics of a Zener diode. So it is the circuit diagram for reverse bias characteristics of Zener diode. So here the cathode of the diode is connected to the supply positive, and anode of the diode is connected to the supply negative. To measure the reverse voltage, we have connected an voltmeter across the device, and to find the leakage current, that is reverse current, the ammeter is connected in series with the diode. So in this tabulation, you can note down that the reverse voltage, that is for an applied voltage, what is the reverse voltage and what is the reverse current, corresponding reverse current, we have to make a note, and we have to draw the graph. So here you can see the experimental setup of reverse characteristics of Zener diode. If you see here, the supply positive is connected to the cathode of the device. So this is called reverse characteristics of Zener diode. So if you see the voltmeter, initially the supply voltage is 0, and the current is also 0. So reverse bias means the device will act as a blocking mode, or the device will be in blocking mode. So the voltage will be more and the current will be very less. So more or less we will get the reverse leakage current only, right? So if you are increasing the apply voltage, the voltage will be increasing. You can notice that the current value is very minimum, right? So further, if I am increasing the apply voltage, you could see the voltage increment and corresponding current increment. So after the 5 volt, the voltage value will be constant and the current will be further increasing. So you can see that the voltage is constant and the current is getting increased. So the diode we used as C5V1, that means 5.1 volt. So after 5.1 volt, in reverse bias characteristics, the voltage will be constant, but the current will be increasing. So that we can see in reverse characteristics, the Zener diode can act as a voltage regulator, right? So after making a note of all the readings, we have to draw a graph. So you can see the graph over here. So in x-axis, that is in this x-axis, I have taken the reverse voltage, and y-axis I have taken the reverse current, right? So only that is from 0 point, if you are noticing, only we are getting the reverse leakage current, but after 5 volt, the voltage is constant, but the current is getting increasing. So this is called reverse characteristics of Zener diode. So this is the overall graph of VA characteristics of Zener diode. So experimentally we have taken the readings and we have plotted the graph. So here it is forward bias and here it is reverse bias. So after plotting the graph, we can find out the forward resistance of the diode by drawing a slope across this graph. We can take change in forward voltage and change in forward current. The ratio between change in forward voltage to the change in forward current is called as resistance, that is forward resistance of the Zener diode. So after doing all the things, we have to write a result. That is VA characteristics of Zener diode has been analyzed experimentally. So like that we have to write a result, and those results will be verified with the help of multi-sim simulation tool. That's all. Thank you.